Fractional distillation isn't exactly a one-size-fits-all solution. There are a few scenarios where it might not be the best approach. For starters, it really relies on having a mixture with components that have significantly different boiling points. If the liquids in the mixture are too close in temperature, it becomes a real challenge to get a clean separation. You end up with a lot of overlap and cross-contamination between the fractions. Another limitation is that fractional distillation is not so great at separating out azeotropes, those pesky mixtures where the vapor and liquid compositions are the same. Water and ethanol, for example, form an azeotrope that's tricky to break apart using just distillation. And let's not forget about the energy costs. Heating up all those liquids and maintaining precise temperature control takes a ton of energy. For some applications, the high operating costs might make fractional distillation a less viable option. But don't count it out just yet, my young chemists. Fractional distillation is still an incredibly useful technique, even with its limitations. It's all about knowing when to use the right tool for the job. If you're looking for exercises to test your knowledge, there is a link in the description for you. Thanks for sticking around till the end. If you enjoyed the video so far and want to see more content like this, make sure you hit that subscribe button. Thanks for watching.